Ocean weather and seismic reports were also sent back routinely. Cameras began returning pictures, thousands of pictures. Color photographs showed a surface littered with rocks. A fine dust, red or yellow-brown, could be seen everywhere. We even had a chance to view the two moons of Mars, Phobos and Deimos. Viking's complex science and technology were considered to be a triumph equal to the landings on the moon. Two unmanned Voyager spacecraft carried a record with the sights and sounds of Earth, just in case they encounter a cosmic neighbor along the way. Their interplanetary journey was designed to take them past Jupiter and Saturn, and eventually one Voyager was to pass close to Uranus and Neptune. Voyager's sensors recorded Jupiter's intricate weather patterns and detected massive lightning bolts in its churning cloud tops. It took 40 minutes for a signal from Voyager passing Jupiter to be received by mission controllers at the Jet Propulsion Laboratory, so the spacecraft had to be essentially automatic. Voyager also took a good look at Jupiter's largest moons. There's Io with its active volcanoes. Europa. Ganymede, the largest moon, appears to be a mixture of rock and ice. And Callisto, probably the oldest of the four. The Voyager's next assignment was to fly by Saturn and its moons. Saturn's vast ring system is made up of many small particles that orbit the huge planet in wave-like patterns. Its atmosphere is buffeted by a strong jet stream that blows eastward at 1,200 miles per hour. Voyager detected the hottest gases ever observed in the solar system, up to 1 billion degrees Fahrenheit. As of now, 2/3 of the planets in our solar system have been explored, and by the end of this decade, we will have explored most of the rest, including Uranus and Neptune. Through the years, the single most constant in NASA has been, is now, and continues to be its aeronautical research. It is a common thread that is woven throughout the agency. It has influenced everything that flies, both on Earth and in space. There is little doubt why this country has been the world leader in things aeronautical. Here are some of the goals of the program. Make aircraft more energy efficient. Fly higher, faster, and farther on less fuel. Lower pollution. Systematic improvement of engine components. Reduce weight through use of light but very strong composite materials. Study problems associated with wake vortices, tornado-like patterns of air that trail off behind jet aircraft, causing problems for smaller planes following closely in their wake. Airplanes are America's leading industrial export, thanks to NASA's research and development programs. Since there are some 200,000 general aviation aircraft in this country, NASA research is also improving this class of airplanes. Crashworthiness and stall spin studies are good examples. problem of potentially crippling ice formation is also being worked on. The heart of this research is a unique refrigerated test tunnel capable of simulating the icing conditions an aircraft is likely to encounter. Once a test has been run, newly developed computer codes are used to evaluate the results. During the early days of manned spaceflight, consideration was given to using a parawing to return astronauts and spacecraft to Earth. While this method was ultimately discarded, it did produce a rather interesting new sport. There has been extensive work done on planes that take off and land vertically. Ones that need very short runways. Hybrids that are combinations of airplane and helicopter. And oblique wing craft that reduce air drag by pivoting the wing at various angles to the plane's fuselage. The expertise used to make airplane propellers better has also been applied to powerful wind turbine electric generators, including some of the largest in the world. NASA's aeronautical research was the seed from which the space program would grow. A prime example of this was the Lifting Body project that began in the early 60s. The combination of wind tunnel tests and actual flights led to the design of the reusable space shuttle. When the design and wind tunnel work was complete, a series of approach and landing tests were scheduled. Since the orbiter has no power for landing, its ability to land easily with only one try was critical.
Gears coming. See the gear coming. It's down. 30 feet. 20 feet. 10 feet. 5 feet. 4 feet. 2 feet. 1 foot. Down.
The Enterprise's near-perfect landings gave final proof that the shuttle orbiter was a flyable, landable craft. The years of research and development would now be put to the ultimate test, the first flight into space of Shuttle Columbia with astronauts at the controls. There was an air of excitement as the brand new shuttle moved from its processing facility at the Kennedy Space Center to the vehicle assembly building, where it would be mated with rockets and fuel tank and rolled out to the launch pad. Never before had a new spacecraft been flown this way. Previous Mercury, Gemini, and Apollos were man-rated in advance, meaning that unmanned flights were flown before putting an astronaut crew on board. Despite nagging problems with engines and protective tiles, there was a quiet optimism. Longtime space workers knew from past experience with the lunar landing program that design and engineering problems do get worked out. After one false start, astronauts John Young and Robert Crippen headed for the launch pad.
Seconds. That goes into the interior, and the astronauts are
Columbia's maiden flight would be brief, just 54.5 hours, 36 orbits, and return to Earth. But it signaled the beginning of a reusable space transportation system.
To ensure that everything is in the proper place.
10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine start.
Roger, Columbia. You've got your normal Capcoms back now.
Okay. Well, the only bad part about it, Joe, is we're going to have to come down.
Three, two, one, down. 5, 4, 3, down.
Look at the sand! Look at the sand!
That's a good picture, John, coming down.
John Young's not going to wait for Dr.
One overboard first.
30 weeks later, after Columbia had been returned to the Kennedy Space Center, cleaned, refurbished, and rolled out to the pad, astronauts Joe Engle and Dick Truly flew Columbia into space again. While an imaging radar system mapped distant Earth, the crew made a critical test of a Canadian-developed mechanical arm that would later place payloads into and out of orbit.
Okay, we copy. Thank you.
Looks like it's a little cloudy out here, Sally. It's a good thing the Sir AC did that. And we can hear it crank up on the board.
Okay, stand by. Okay, we see fan A on, and we'd like you to take broad.
As Columbia landed the second time, the circle was complete. A new generation of space travel had begun. When Space Shuttle 3 left the launch pad, it carried an experiment prepared by 18-year-old Todd Nelson of Rose Creek, Minnesota. An experiment to study the effects of weightlessness on insects in space. It's called the Shuttle Student Involvement Project and includes NASA, the National Science Teachers Association, and industry sponsors who help transform winning proposals into flight experiments. Since this first flight, young people in high schools around the country have developed and flown a variety of experiments, ranging from medical projects to the study of zero gravity on an ant colony. They are setting an example for others who may be encouraged to pursue careers in science and engineering, something that ultimately can be translated into technological leadership for the U.S. 12 weeks passed. Then, astronauts Ken Mattingly and Henry Hartsfield piloted Columbia on its fourth and final test flight. The spacecraft's performance made it possible to certify the Space Transportation System a fully operational carrier. As they landed on July 4th, the crew was greeted by President and Mrs. Reagan. Space Shuttle 5, the first operational flight. 2 commercial communications satellites were hauled into orbit, one for satellite business systems and one for Telesat of Canada. Their deployment was a complete success.
Did you get it? You don't have it, obviously.
I got it.
Space Shuttle 6 was the second operational mission and Flight 1 for Challenger, this country's newest spacecraft. After launching a 5,000-pound tracking and data relay satellite from the payload bay, mission specialist astronauts Story Musgrave and Donald Peterson became the first Americans in 9 years to walk in space. Practice needed for satellite repair work.
Due for my massive article, rotate around and get it on the right side.
Story?
Yeah.
Big caddy up here where it says tape on the left-hand door.
Yeah.
Mission 7 carried a crew of 5 into space, including America's first woman astronaut, Sally Ride.
For main engine start, we have main engine start and ignition and liftoff. Liftoff of STS-7 and America's first woman astronaut. And the shuttle has cleared the tower.
She and mission specialists John Fabian and Norm Thagard deployed a pair of communication satellites for Canada and Indonesia.
The colors look good.
Roger that, looks great.
Shuttles 1 and 2 were now operational. With the addition of a third orbiter, Discoverer, to the fleet, and with literally dozens of astronauts in training at any given time, this new space transportation system would begin delivering in earnest and with increasing frequency. Opening a new era in science is Space Lab, where scientists from around the world work together in a unique international research center aboard NASA's Space Shuttle. Built by the European Space Agency, Space Lab is creating exciting new opportunities for research in all the sciences and is making routine international cooperation a reality. Looking farther ahead, there's the Space Telescope that will expand our vision almost to the edge of the universe. The shuttle gives the United States an unrivaled tool for the practical use of space. Historically, the space program has proceeded in a building block fashion, and toward that end, NASA has begun looking at the next logical step, a possible future space station, a permanent presence in space. The station would serve as a scientific and technological laboratory, as well as an operations base from which satellites could be serviced and large structures assembled. One of the highest priorities is to develop a clear understanding of a station's proper role in the total space program, so that if and when it is proposed for development, the station will be a truly significant national asset, one that would ensure continued American preeminence in space.
The space program in general and the shuttle program in particular have gone a long way to help our country recapture its spirit of vitality and confidence. The pioneer spirit still flourishes in America. In the future, as in the past, Our freedom, independence, and national well-being will be tied to new achievements, new discoveries, and pushing back new frontiers. We must look aggressively to the future by demonstrating the potential of the shuttle and establishing a more permanent presence in space.
The 25th anniversary of NASA. To a casual observer, NASA is identified by launch vehicles and spacecraft and airplanes and wind tunnels. But it is the people behind it all who are really important. It's the people who think and dream and work to make these things possible. That is the true measure of NASA's strength and its successes. And it is to the next generation of space pioneers, the youth of the world, that this program is dedicated.